Hello everybody, my name is Neutron and welcome to my first ever YouTube video. In this tutorial we'll build a Python library called Plank that is focused on making physics graphs. I expect you to have some basic knowledge about Python such as functions, for loops, but in this tutorial you will learn more about Seaborn library, pandas, matplotlib, and a lot more. So I will be using JupyterLab for this tutorial, but you can use a simple text editor. Just know that Jupyter is usually faster in compiling code. So let's create a new notebook and let's change the name to Plank. And in first block we'll just define constants and import libraries. The first library we'll use is simply math for mathematics functions. Second one is matplotlib.byplot as PLT, and we'll use Seaborn as SNS. If you don't know, Seaborn library is used for drawing beautiful graphs. And finally we'll use pandas as PT. And pandas is used for better data cleaning and data manipulation. And also let's define a constant G, which is the gravitational acceleration, and it's equal to 9.81 approximately. Let's run this one and let's see if there are any errors. So there are no errors, we can move on. The first function we'll create will be called motion graph, and this function will be simply graphing motions for us. So for example, let's start commenting. We'll have several arguments and all arguments will be predefined. So first argument will be velocity equal to 0, and then we'll have s, which is distance, and time, which is also equal to 0. Let's define them all here. And lastly we'll have a different argument called specify. Specify is a string and it will be used from the user side to specify what type of graph they want to see. So let's go here and define specify and add several options here. For example, PT will be position time graph, VT will be velocity time graph, and lastly AT will be acceleration time graph. And I forgot to add A, which is acceleration here. So now let's start drawing the function. First we have to write if specify is equal to PT. So that means if the user chooses a position time graph. To draw a position time graph, we have to make sure that S and T are not empty and that they are of instance panda series. So we write if not instance is instance and here we write S and PD series. So what this does is make sure that the variable S that was passed from the user is panda series. If it's not, we do it like this: S is equal to PD series V for V in S. So for every variable in S, which will be a list if it's not PD series, we turn that into a panda series. Then we do the same, we copy and paste it with T, time, and here we just change this to T. So now we have two series, and what we have to do now is turn them into panda data frames to be able to draw them. So here we create a data frame, df is equal to pd empty data frame, and then we will use a pandas function called assign to assign series. So first we'll assign position, this will be a string, is equal to s values, so the values of this series. Then we copy this and change position to time. So this is column name. So this is position column and this is time column, and we change this to T. And all we have to do now is draw the graph. Variable G is equal to SNS. We are using Seaborn library. Line plot where X is equal to time, Y is equal to position, and data is equal to data frame. And then we just set the labels. G is equal to G set Y label is equal to position, and X label is equal to time. Let's run this and see. Oh, here we don't use this. We have to get rid of the quotes. Let's run this. And now let's run this function. S is equal to 1, 2, 3, 4, 5, and then again 4, 3, 2, 1, and T is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and we specify this as PT. Let's run it. We see that we get the accurate graph. First, in the first 5 seconds, the position increases, and then it comes back to the same place, so it goes down again. Now, let's write this code for these two other specifications. We'll just copy this, and here we write L. So L if, which means else if, specify is equal to velocity time. So we change all V's to all S's to V here, and here instead of V we'll write VA, which will stand for value because V is taken here, and then here we write velocity is equal to V values, and change position to velocity here too. Now let's change this to VT and run both of them. Int object is not iterable. We write is if f is not a v is not equal to series, and change s here to v, so we get the same again. Now we can do this for acceleration. Again, copy this and change all v's to a. Okay. Now let's change the values a little bit. Let's change it to 10, 15, 50, 90, 100, and let's see if this works. So we need to add one more. Let's do 2000. Oh, we have to add it here. 10, 11. So we see we get the accurate graph. So this function is ready. The only problem we have now is that we have a lot of repeating code. So first, in all these three functions, we check if in all these three statements, we check if it's instance series, then we create a data frame, and then we draw the graph. So to avoid repetition, what we'll do is create a helper function, draw graph. And helper functions are used to avoid repetition or for recursion. So let's copy this and put it here. So how do we do this? We see that all the code is same. The only thing that changes is the variable here. So we'll have two series, series 1, series 2, and we'll change all A's to series 1, and all T to series 2. Okay, and then let's change this to series 1 and series 2. So here x is always series 2 and y is series 1. Okay, and then we'll write x label and y label, and here y label is equal to y label and x label is equal to x label. So now let's check if this works. Let's call draw graph function where series 1 is equal to a, series 2 is equal to t, x label is equal to time, and y label is equal to acceleration. Let's run this. Name t is not found, so where is t here? Okay, and here we change t to series 2. A is not defined, series 1. So we see that we get the same graph with only this line. So now we can change all of these to that. V and velocity, and here S and position. So our function is much shorter now. Let's see if this works. We'll change it to V and let's change some values. Let's just randomize them. Let's run this. Int object is not retrievable again. Oh, here we change this to V. Yeah. So we see that we get the same graph. The maximum happens at 390 and then it decreases. So let's do it here, and let's change the maximum a little earlier, and let's change it to as position time graph. Yes, the maximum happens, it decreases a little and then it decreases more. So we got our first function already. In the next tutorials we'll write about projectile motion and circular motion. Thank you for watching.